I'm in StatCrunch and I'm going to do a paired t-test. This data has been taken from one of the tutorials where we did the reaction distance experiment. So this is where we dropped the ruler through somebody else's hands and they caught it, and the further up the ruler it was when they caught it, the slower their reaction distance, I suppose, which you could convert into a speed or a time if you wanted to. Each tutorial may have conducted the experiment slightly differently, so the data you have from your class might not look like this. What this class decided to do was to collect the reaction distance for the dominant hand and compare that with the non-dominant hand. So we have two observations for each person, and so each row is one person. To do the paired t-test, we would go to Stat t-test paired, the first sample, the second sample. We can save the differences if we want to. I don't know if you'll need those, and then you can choose to do a hypothesis test or the confidence interval, and you may want to go through this twice and get both of these. With your hypothesis test, the null hypothesis is that there is no difference between your dominant and non-dominant hand. The alternative is the default is a two-sided test. If you have a very good reason for believing that the test should be one-sided, then you can do that, and you should justify that in your report why you have decided to do that, and then click compute. Easy as. So there is the test. It gives us the null hypothesis, it gives us our test statistic and the p-value. Very high p-value, so we have got no evidence that there's any difference between the reaction distance for the dominant and the non-dominant hands. In this case, very small data set. And actually the data set was even smaller. I had to double it just to get 16 observations. So obviously this is not a real analysis. Now you can go through that again, just exactly the same options, t-stats paired, and get the confidence interval out for the difference. So the difference in reaction distance between your dominant and non-dominant. And mu1 will be whatever you selected up here. So that will be the dominant minus the non-dominant. And you need to know which way around this difference has been calculated in order to interpret the results if you do get a difference. And we don't really need to save the differences there, we've already got them. So compute. And now we've got our confidence interval as well. So that's it.